Okay, today we're going to be talking about uh, a rule called power of a power. And what that really means is that we're going to be raising an expression to a power, not just a single variable, but an exponential expression. The first thing we need to think about, though, is that a sub n is equal to a multiplied n times. And we're going to use that when we raise an exponential expression to a power. So here we have the exponential expression a to the third, and it's going to be raised to the second power. So in order to do that, we're going to multiply a to the third times itself 2 times. Remember, an exponent tells us how many times to multiply something by itself. Now, each one of those a to the thirds can be rewritten or expanded as a times a times a, and you can see how we have expanded the a to the third that was in red and the a to the third that was written in black. Now, if we look at that, we have a being multiplied 6 times. So now we know that a to the third raised to the second power is really a to the sixth. In another example here, we have x to the fourth raised to the second power. Well, x to the fourth raised to the second power tells us that we're going to multiply x to the fourth times x to the fourth. Then we're going to expand. So we have the x to the fourth in red has been expanded to the 4 red x's being multiplied together, and the x to the fourth in black has been expanded to the 4 black x's multiplied together. And when we look at that, we have 8 x's being multiplied together. So that gives us x to the 8th. Again, we can see that x to the fourth to the second power is equal to x to the 8th. Now, going through the expansion, as we know, as we have looked at other examples, often is very time consuming and it causes us to write a lot down, and we would really like to look for a shortcut. And that's what we're going to do right here. So we're going to first look at our exponents. We're going to bring them down away from those bases so that we can kind of take a look at them and see how they're related to each other. And as you look at the 3, 2, 6 on the left-hand side and then the 4, 2, 8 on the right-hand side, hopefully you can see that if you multiply 3 times 2, you get 6, and 4 times 2, you get 8. So the exponent that is inside and then outside the parentheses, if we multiply it, then we get the exponent of our answer. That leads us to a general rule that a to the n raised to the m power is equal to a to the n times n. That means that when we are raising an exponential expression to a power, then we're going to multiply those exponents in order to find our answer. Here are some for you to practice using that rule. So remember, when you're multiplying a power or raising a power to a power, you need to multiply exponents. Also, remember your rules for when you are multiplying numbers, you add exponents, or multiplying like bases, you add exponents. And then when you are dividing like bases, you subtract exponents. When you are finished, you may come back and check your work, but for right now, you should pause so that you have time to work. Okay, welcome back, and we will continue on to check your work. Here, in the first example, you see that 3 to the fourth to the third power. We're going to multiply those exponents. 4 times 3 is 12, so we get 3 to the 12th. In problem number 2, we get 10 to the negative 2, all of that raised to the negative 8 power. Negative 2 times negative 8 is positive 16, so we have 10 to the 16th. In problem number 3, we have 7 to the third raised to the negative 5 power, and 3 times negative 5 is negative 15. We do not like to leave negative exponents, so we're going to rewrite that as 1 over 7 to the 15th power. And then in problem number 4, we have 2 to the fourth raised to the 8th divided by 2 to the 10th. Well, 4 times 8 is 32, so we have 2 to the 32nd over 2 to the 10th. And when we are dividing, we subtract exponents. So 32 minus 10 is 22, which leaves us with 2 to the 22nd power.